Thank you. Okay. Climate crisis. What climate crisis? The weather seems pretty good to me. Unfortunately, the science makes clear the climate system, the physics of what we're doing by burning fossil fuels and putting carbon dioxide and other gases in the atmosphere is very simple. As the atmosphere becomes more opaque, these gases absorb infrared radiation, that's heat radiation. So as the atmosphere becomes more opaque, more murky in the infrared or thermal spectrum, it traps the Earth's heat radiation so that you temporarily have an energy imbalance with more energy coming in from the sun than heat being radiated to space. And of course, if there's more energy coming in than going out, then the planet is going to get warmer. And that is what is happening. But the system does not respond quickly because the ocean is 4 kilometers deep, the ice sheets are 3 kilometers thick. It takes time. That inertia is what is the source of the difficulty in people understanding what is happening. It means that we've only experienced part of the warming due to the gases that are already in the atmosphere, and we're continuing to add more all the time. So over the last several decades, the planet has warmed up over the last century by 0.8 of a degree Celsius, which is 1.5 degrees Fahrenheit. It fluctuates from year to year because of the natural variability of the system, especially in the Pacific Ocean, the El Nino-La Nina cycle. But if you average over 5 years or 11 years to take out the solar cycle and this Pacific variability, you see that it's been pretty much a linear warming trend. The last, you probably have heard in the media that global warming has stopped in the last 15 years because 1998 was a very warm year with the strongest El Nino of the century. But if you look at that carefully, you see that that apparent flattening is associated with the tropical El Nino Southern Oscillation cycle. During the La Ninas, the cool phases, the planet, the global average temperature is lower, and you can see that we've had 2 strong La Ninas in the last 5 years, which have left the impression that the warming has stopped. But in fact, if you compare the last 3 El Ninos, the one in the late 1990s and the last 2 in the last 5 years, you see that each successive one is warmer. The global temperature is warmer than the previous one. And likewise, in the warm phases, each one has been warmer, with the warmest year being 2010. And in the next couple of years, we're almost certainly going to see a higher temperature than has been measured in the period of instrumental measurements. And we know that the planet is going to continue to get warmer. Next decade is going to be warmer than this one. How do we know that? Because we can measure that the planet is out of energy balance. Now we have these several thousand floats distributed around the world's ocean, which dive down to a depth of 2 kilometers and measure the temperature, among other things, and then come back to the surface and radio the information to a satellite. And we can measure most of the excess energy that's coming into the planet has to go into the ocean because the atmosphere has a very small heat capacity. And what we measure is that the planet is out of balance by about 0.6 of a watt per meter squared. And so the planet, so that means that there's almost as much warming that's in the pipeline as that which has occurred. And this imbalance, the period of measurement, was during the deepest solar minimum in the period in which the sun has been accurately measured. The sun does vary in its brightness. And that, however, the amplitude of that variation is about 1/4 of a watt, so that if we go into a phase with a weaker solar cycle, it's about 1/10 of a watt cooling, which compares to this energy imbalance of 6/10 of a watt. So the solar variation is not negligible, but it's small compared to the greenhouse gas effect. So we know that next decade is going to be warmer. And well, this is showing the same thing with the sunspots. So it's possible that we're in a relatively weak time for the solar variability, but as I mentioned, that effect is small compared with the greenhouse gas effect. And what are the implications of that? Well, I think particularly important are the irreversible effects. And one of those is the potential for sea level rise. We know that the last time the world's temperature was 2 degrees warmer than pre-industrial, which is about 1 degree Celsius warmer than today, sea level was at least 5 meters higher, possibly as much as 6 to 8 meters higher. We don't know exactly how long it will take for the ice sheets to respond, but if we look at the paleoclimate record, we see that there's a perfect correspondence. When the planet gets warmer, ice sheets melt and sea level goes up with a time scale that's no longer than of the order of a few centuries. And what we see now with the gravity satellite measurements, we can measure the gravitational field so precisely that we can see changes in the mass of the Greenland ice sheet and the Antarctic ice sheet. And what we see is they are beginning to lose mass at faster and faster rates. Last year, Greenland lost 500 cubic kilometers of ice, and sea level is going up 3.2 millimeters a year, which is about 14 inches a century, which is more than a nuisance, but it's not really disastrous. But the rate is increasing, and if we allow the planet to get 2 degrees or more warmer, then we know that we're going to get sea level rise of many meters, and all the coastal cities in the world will be, in effect, lost. So we don't want that to happen. Another irreversible effect is the extermination of species. We're putting stresses on many different species for a number of different reasons, but an overriding effect, if we allow greenhouse gases to continue to increase rapidly, will be the shifting of climate zones, which is already beginning. We can measure the shifting of the zones that's happening with warming. Just as an example, I like to show the monarch butterfly because it has both other stresses and the climate stress affecting it. And this happens to be, so with my grandchildren, we plant milkweeds because the other big stress on monarchs is the pesticides, Roundup, the things that kill milkweeds, which is the only thing that the caterpillars of the monarch butterfly can eat. So we plant these milkweeds, and and we've noticed that the number of monarchs has been decreasing over the last few decades and in just the last few years. But 2 summers ago, there was this one broken wing monarch which hung around our yard for 3 weeks and produced a lot of caterpillars, which are a little hard to see in this figure, and then the caterpillars go and form these chrysalis, and eventually we could see at the same moment there were 2 butterflies emerging from their chrysalis. One of them was this male, one of them was this female butterfly. And however, we wondered how many of these butterflies were going to make it to Mexico. You know, the monarch is a remarkable insect. Over an annual cycle, they hibernate in a small area in the Mexican mountains in central Mexico. And and then go north all the way to Canada during the spring, and then come back during the late summer and fall and fly all the way back to Mexico and somehow find their way to this small area in the Mexican mountains. But they have to pass through Texas, and this 2 years ago, 2011, there was this very strong drought in Texas, so we wondered how many of them would make it. Well, here's a photo of some of them that did make it in one of the fir trees in Mexico. It was sent to me by a Mexican scientist who studies these butterflies. That's his son looking at the butterflies. And what he saw, however, at the top of these trees was that the trees are really stressed because of this shifting climate zones, which is making it too dry and hot where these trees have grown for millennia. So the scientist is trying to persuade the government to plant trees higher up the mountain where they would have a better chance. But he also calculates that by the end of this century, if we keep burning fossil fuels as we are, that the mountain won't be high enough for these trees to survive. So that's an example of the danger that we could exterminate that species. And in fact, that year, there was a 30% decrease in the number that made it to Mexico. And then the next summer, there was a bigger drought in the United States, and the number that made it to Mexico was 59% less than the year before, so that now they're down to 7% as many monarchs as there were 25 years ago when the measurements, when they started to count the number that made it to Mexico. So here, another example of the stresses is coral reefs, which are the rainforests of the ocean. About 1 million species are associated with coral reefs, which we're now losing at a rate of more than 1% per year because of the warming of the ocean surface, which causes bleaching of the coral reefs and causes them to expel the symbiotic algae, and also the acidification of the ocean and some other stresses. So that's another danger if we allow warming to continue that will drive many species to extinction. We're also having regional effects. The distribution of temperature anomalies is now shifting toward warmer values, so that the extreme warm events that occurred only a few tenths of 1% of the time, the extreme summer anomalies, are now occurring about 10% of the time or cover about 10% of the area, as happened in 2011 in Texas and Oklahoma, and in larger areas of the United States last summer in 2012. And these warm events occur where the weather patterns are such that you have high pressure that summer, blocking situations where you have continual high pressure. And that causes an increase in forest fires. We see that occurring not only in the United States, but in the Mediterranean region, Australia. But also, as the atmosphere becomes warmer, it holds more water vapor. So that means when you do get rain, the times and places where that occurs, you will get heavier rains and greater floods. We've had 300-year floods where we live in Pennsylvania in the last few decades, and that's common in other places of the world. The conclusion is that we cannot burn all of these fossil fuels. We've burned only the purple parts of the conventional oil, gas, and coal. And we know that we can't burn all of the coal or the unconventional fossil fuels without creating a different planet. We would be heading the planet back to the ice-free state with sea level more than 70 meters, which is more than 200 feet higher than it is now. So we can't do that. The science is crystal clear, and yet governments are pretending that we can just continue. We would need to phase out coal, and we would need to leave unconventional fossil fuels like tar sands and tar shale in the ground. But in reality, we're going right ahead. This is tar sands in Canada. Makes a pretty awful scene after they've scraped off the forest to get at this tar sands. It's this goop which is carried by these giant vehicles. Here's an array of them as they're moving, and they do some preliminary processing on site, dumping the waste into large lagoons. Here's a bird that stopped by for a drink, which will be his last drink. It creates some jobs, not exactly great jobs. So what do we need to do? The thing is, fossil fuels appear to be the cheapest energy. That's because they're partially subsidized and they do not have to pay their cost to society. They don't pay for the human health effects of air pollution and water pollution. They don't pay for the climate effects that are caused by greenhouse gases. So what we need to do is collect a fee from the fossil fuel companies at the source, at the domestic mine or the port of entry, and that money should be distributed in equal amounts to all legal residents so that people who do better than average in limiting their fossil fuel use will actually make money. And this will be a tremendous incentive for entrepreneurs to develop low carbon and no carbon energies and energy efficient products. This is a transparent, market-based, conservative way to solve the problem, and it would stimulate the economy. We would actually be much better off economically if we would do this and make fuels pay for their honest cost. My advice is the most useful thing we can do is, at this point, is to try to persuade our governments, and that is going to require a lot of people understanding that we need to put an honest price on fossil fuels, but it's one which the money does not need to go to the government. We finally have succeeded in persuading some politicians that the need for doing this. A problem is then in the case of when the Democrats propose a bill, they want to take half of the money or 40% of the money for the government to do the things that governments want to do. But that, in effect, makes the government bigger or allows it to stay bigger, and you're never going to persuade conservatives. And you don't want that, because if you give 100% of the money to the public, then with the present distribution of energy use, 60% of the people would get more money in their dividend than they pay in increased prices. But if they want to stay on the positive side of that ledger, they'll need to pay attention to their carbon footprint. And if that price continues to rise, and there would be no significant opposition to that, since most people will get more in their dividend than they pay in increased prices, then we can in fact move to the clean energy future. But it's not going to happen without that. We can't just go out and ask and try to persuade the government to build more, to subsidize renewable energies like solar panels and windmills. You're not going to solve the problem that way. We have to address the fundamental issue that fossil fuels appear to be the cheapest energy. And the way to address that is to put a fee on carbon that rises slowly over time. And there is this organization, Citizens Climate Lobby, that understands this. They're growing rapidly, but still small compared to what is needed to get governments to actually do what is needed. Now, I think that's my last chart. I'll just point out that this is also the kind of action that is needed that could be made international, because all it would require is agreement between the United States and China has every reason, or it could be between Europe and China, or all three of them. But China has every reason to want to not go down the path of addiction to fossil fuels that the United States presently has. So they because they would suffer more from climate change than just about any nation. So I think my time is up, but that's the point I really want to bring home of the need for a rising carbon fee. Thanks.